Okay, I see we still have a few more folks coming into the room. Okay, everyone, we ready? So, first of all, thank all of you for coming. Really appreciate you being here. And I know Andrew's had a heck of a time putting together this conference, and it's been going lovely so far. So, Andrew, I don't know if you're here, but thank you very much. Pardon? Speakers are not working? Pardon? Is it just the... Yes, it is. Ah. User interface error. So, nope, it's me. I'll remember that. Okay, let's try this again. So, anyway, as I was saying, very grateful for Andrew for all the work he's put on at this conference here in Riga. It's my second time in Riga, lovely city, like it here. This is actually the second time I gave this talk. A few times was a few years ago, but for various reasons it didn't get put on the web right away. So this is, if you've seen it before, this is still a heavily updated version of this talk. My name's Curtis Ovid Poe. Most of you know me. All around the world at FR, we get called in to solve hard problems for companies and sometimes to make their Oracle database go away. That always makes me happy. And, oh yes. So today we're going to talk about testing lies. The first title is a lie, because this is going to be a lot of testing misconceptions and ideas that we have. But first, I just want to explain the question policy. I usually have this slide at the beginning of all of my talks so that people understand. Usually I like people to save their questions towards the end so that if we have time, we can have questions. This gives me a better chance of keeping the talk on time. In this particular time, you know, if you do have a question, is it still problematic? That was the next part I was getting to, believe it or not. I do have a small favor to ask about my question policy. So you can go ahead and interrupt me during the talk. Please hold up your hand, be polite, but a small favor to ask. I have a nasty habit when people ask me questions to answer them, which is great for you guys, except on the video they don't hear the questions. So if I forget to repeat back the question, I want all of you to shout out, "What's the question, moron?" Can we do that? That was beautiful. Okay, so before we talk about this, a little bit about me and my testing background. I wrote the TAP harness, which currently ships with Perl. You probably don't know about it. It's actually the test harness that you have is a wrapper around test harness for backwards compatibility. I wrote test most, which basically is a heuristic analysis in the most popular testing modules on the CPAN. I put it on there. And then I realized just because that's popular doesn't mean it's necessarily the best set of testing modules that you need. So I put together Test Kit, which allows you to choose the testing modules that you want. And Test Kit was I'm proud of myself. It was a brilliant idea. The code sucked. So Alex Ballhatchett, I think that's how I pronounce his name. He released Test Kit 2. I wrote Test Class Most to combine Test Class and Test Most. And everyone kept asking me, how do you combine Test Class and Moose? Because they don't play well together. So I just wrote Test Class Moose, which a lot of large organizations today are using to drive much larger test suites. I wrote Test JSON, Test Aggregate, Test Tap, Test Sync Have Want. You've never heard about it, and you probably don't want to. Solves a very annoying problem, and contributed to many more modules. I also teach software testing. I fix test suites for company. My book, Beginning Perl, Chapter 14, is all about testing. I wrote the Zen of Test Suites, which kind of starts to give you a hint about the difference between application and module testing, but I need to do some more work writing that up for folks, which all goes to say, I know testing. I've been doing this for a long time. I've been doing automated testing for about 20 years now. And when we start out, we're often what we call test infected. We learn about the beauties of TDD. Well, I want 100% code coverage, and I'm gonna unit test everything, unit tests all the way. And then you get a little bit more experienced with testing, which is you need to start thinking about what you're doing. But from the business standpoint, why do you really want to test? Why do you really care? So this has been verified repeatedly. The relative cost of fixing defects, design is always the number one thing. This is one of the problems with Agile. We tend not to do a lot of design up front, so we get tripped up. But otherwise, design is the best place to catch your defects. You catch defects in design, you will do a much better job of keeping your total error rate down in your code. You have the implementation stage, where then you find the defects in your design, and you correct them, and you put them in there. Then you have the testing phase, where you find the defects in your implementation, and then you have to go back and fix that, which may have defects in design. So by the time you get to testing, fixing a bug is about 15 times more expensive. Maintenance, it's about 100 times more expensive. 2 orders of magnitude more expensive to fix bugs once they actually get out into the wild, which I won't go into the reasons why, but basically catch bugs early. It's important. But first, you'll notice I have a little citation down there. This is one of the most beautiful SlideShare presentations ever by Dr. Greg Wilson, Bits of Evidence, and all he's talking about is evidence. Evidence is terribly important because we have a lot of evidence that evidence actually works. So computer scientists, they love evidence. Real other scientists love evidence. Computer programmers love anecdotes. You know, it's word of mouth. What we feel is good. What we think is good. And we'll defend these anecdotes quite firmly. And this is kind of a problem when we're trying to figure out a better way to write software. Or in our case, writing tests. So evidence, that's basically something which tends to prove something, grounds for belief. Well, what I mean by tends to prove is just because we know something today, we might get more information later which overturns that, and that's fine. We don't want to be dogmatic about anything. And when I'm talking about evidence, I want to make it clear that absence of evidence is not evidence. Evidence of absence is. And what I mean by that, for example, is, there's no evidence that gods exist. None. There's no evidence that gods don't exist. This is for most modern definitions of God, how they've evolved over time. You know, instead of being Thor hammering a rock, we have these more nebulous things that we pray to or whatever. This is outside the realm of evidence. It's outside the realm of science. This is religion. And this is fine. There's nothing wrong with that. This is your personal opinion. But this doesn't help you, in our case, write test suites. But I also want to make it clear that personal experience isn't necessarily a bad thing. And this is something to keep in mind. So when we're talking about smaller subroutines, or smaller methods. I know I would much rather read a 10-line subroutine than a 150-line subroutine. It's easier to follow, it's easier to maintain, and what a small subroutine is varies. And you want to compare a small subroutine or method in Java versus a small method in Perl. There's going to be a bit of a difference on what we mean by small. But this is the sort of thing we are driven by personal experience. So by the way, am I preaching to the choir? Hold up your hand if you know that small subs are better. Okay, I see a lot of hands held up there. I lied. You're all wrong. Hypothesis. If P, then Q. If P is true and Q is not true, then we can reject the hypothesis. It's fairly simple. There's nothing unclear about that. So our hypothesis said, if you have small subs, then your code is more maintainable and or correct. And there is study after study after study, which proves that this is simply not true. One found an inverse correlation between small size of sub and being more maintainable. Another one found no correlation. Another one found no correlation, but larger is less expensive to maintain. Small routines had more errors. If you have a one-line routine and you have one error, that's 100% error rate. So less maintenance for larger routines was found again. Jones in 86 found 500 or more lines of code in a function before it started having more errors. Part of the reason for this is code often calls out to other code. So if you have subroutine A and you read through it and it's perfectly correct and it's calling out to subroutine B, well, now you got to go and read subroutine B to find out if it's really correct. And even if subroutine B is correct, it may not be correct according to your expectation of what it does, so you could have misunderstood. There's all sorts of problems with making things a little bit too small. And if you put a lot more code in there, a lot of times you can read through there and see everything that's going on. The obvious example of this, the counterexample is just trivial things, like summing a list of numbers. Summing a list of numbers, easiest thing in the world. So that's an example of small things which you can't get wrong, so they're so easy. For example, here I sum a file handle and a blessed reference. List util sum. These are really useful numbers, aren't they? Absolutely useless. So list util, in summing these numbers, it gives you garbage. So, and also, it's not documented in there. So it's very easy, even for a trivial bit of code, to get an error, particularly in dynamic languages where our typing is based around containers and not around the kinds of data that you have. So it's very easy to get something like this wrong. And how many of you use list util sum? How many of you know that this bug is not in your code? All of a sudden, people are afraid to hold up their hands. I don't know why. So reality trumps opinion. Every single time. This was a Ptolemaic view of the universe where the Earth was at the center. We know that's not true anymore. But I came here to talk about tests. I will at times be providing citations where appropriate. Other times it will be use your knowledge, your intuition. If you disagree with me, that's fine. Go ahead and hold up your hand. Call me on it. So, caveats about this. Some of the points are just going to be dead obvious, like small subs are better. Some of the points are going to be maddening. They're going to fly in the face of some beliefs people have about software testing. There aren't a lot of studies because these studies are extremely hard to conduct. Because quite often they're on a small subset of people who know that they're being studied, or maybe on a college student who doesn't have a lot of experience in testing, and they're doing TDD for the first time. It's very frustrating getting good quality studies. I've read a lot of them, and they're junk. So, and always be skeptical, and that includes me. Don't just take my word for this. So let's start with something simple, like code coverage. I mean, you've gotten beyond testing. Now you're getting into the case of code coverage, and you want to make sure all your code's covered. So you want to, code coverage, the first lie is code coverage tells me what to test, and it does not. Code coverage gives you hints about what to test, and it can be misleading. So here, I have a reciprocal function. Is reciprocal to 0.5, reciprocal is correct. That is 100% code coverage. Congratulations. Of course, that's also rubbish. What if I pass 0 or a string? 2 apples will give you 0.5 as the answer, by the way. So obviously we could take the reciprocal of 2 apples. Or, you know, if we pass it on def or a file handle or all sorts of other things. Code coverage can be very misleading even if it's at 100%. So you need to be careful about that. And when you're testing, you need to remember you have a different mindset than when you're writing code. In writing code, you're creating. In testing, you want to destroy. Don't just say, if I give it X, it gives me Y, great, I'm done. It's, I want to destroy this thing. I want to break it. I want to find out what's wrong so that my customers don't. So please keep this in mind. Testing it's a totally different thing here. And we tend to test against our expectations. This is what I know my code does. I test and I verify that it does that. And this gives us a sense of false confidence at times. A lot of bugs creep in this way. So another problem with code coverage is there's a subroutine that's never called. We've got a test for it. And now we verified that this code works. Great, it's covered. But it's dead code. I've had this happen in code coverage. I'm looking through there and, okay, that's covered. Oh, that's not covered, so I better go off and write tests for that. And I've ignored the fact that there's dead code. I'll deal with that in a second. So I have a little routine built into my editor. I just hit comma S, and it gives me a little shorthand of how my particular code's behaving. Here's all my methods, whether or not they're documented, the number of times called. And oh, here I've got a private method, which is never called. So I get reports like that all the time as I'm editing. I hit my comma S, and I get this little shorthand, and I can see, oh, now I've got a problem. And this helps me get rid of lots of dead code. So unit tests versus integration tests. This is one that is kind of a personal bugaboo with me, because a lot of people are saying unit test everything, and there's some interesting questions about what unit tests actually are. Are you mocking up everything so your code can't talk to anything else? Well, but that's all our code does. We have A, B, C, D, and E, and they're all talking to one another. It's that information between them which is really fascinating to us. That's what we really care about, because that's what's going to be going after the customer. That's what's going to be stored in our database. So if you unit test everything, the very first time I learned how to do testing, we had 3 weeks to build a point-of-sale system. We'd never built this before, and I was unit testing everything, and I was actually proud of this, and I was happy. And the first time we tried to launch it, it all crashed because we hadn't done any integration testing. So unit testing is a little frustration there, but it's still highly important, particularly if you have very tricky bits of code. But you can unit test dead code all the time and not notice that it's dead code all the time. I had this one method that was bugging the heck out of me in our Tau Station game, because every couple of months I had to rewrite this test in order to make sure that it was synchronizing with what the code was doing internally. It's a long story, I won't go into it, but basically after a while I realized, oh, I should check to see if it's used, and it was not. So I was wasting a lot of time maintaining dead code, particularly fragile dead code, oddly enough. It's a long story as to why it was fragile and dead. So dead code usually can't be called via your interface. So that's a clue as to something you have with integration tests. So if you're going to try and do some code coverage and use that to find some dead code, it's interesting if you start breaking your code out in different ways of somehow attaching metadata so you can know, is this unit test, integration tests, full stack API tests, whatever. And if you run your tests against your API, then you can get an idea of what code coverage is covering if for the purposes of dead code. Why isn't this code ever getting called by my API tests? Is it because it's very hard to call, or is it because it's not used? So being able to test at that level is very interesting. So there's various different ways you can do this. Like if you're using test class Moose, you can slap tags on things. So I can slap an API tag in there, and then when I run, so this is test class Moose interface has been updated since I wrote this. So this is a little bit different, but basically you specify what tags you want to include, and then get a subset of the different types of tests you want. So that helps you deal with this issue. So somehow it's good to have metadata about your tests. You do it via an XUnit API, maybe file names will give you a clue, directory names, something, so you can logically separate the different parts of your test so you can have a better idea of controlling code coverage to verify things that are going on. You also have a covered but not tested. So this, we have a test forum method. So my site test website, we log in, we get the forum, we follow this link, text off topic, and then we post OK, title, body, blah, blah, blah. That code's not tested, but it's exercised, and Develop Cover doesn't have any way of knowing that. So that's another thing to be wary of when you're using Develop Cover. It's a great tool, but it's very easy to get artificially high code coverage numbers through integration tests and not actually be testing stuff. So this tested that it posted OK, but I don't know if it actually shows up on the website. So it's easy to get caught in that trap. So for Develop Cover, remember 100% code coverage, that doesn't handle data. That idea is reciprocal. You pass in 2 and you get 100% code coverage, but there's all sorts of error conditions that you might want to check with that. It doesn't, you don't want to be covering dead code. It's a waste of time. It's a waste of maintenance. It can be misleading. It's cognitive overhead. Be wary of code that is covered but not actually tested, particularly with this very, very common with deep stack integration tests. So don't blindly trust your tools. Think about them. Stop thinking about what people are saying for, oh, here's what we need for code coverage. And 100% code coverage, I usually don't recommend this for large projects. It's very hard to do. If you're trying to test whether or not your code successfully opened a file handle and it couldn't, you probably have far deeper problems there. If that file handle is just, if all of a sudden something that previously worked suddenly does not. So don't worry too much about 100% coverage. So we tell ourselves, and told ourselves this for a long time, that Perl is most test infected. And in fact, we have a phenomenal testing system with, CPAN testers, getting smoke test reports back all the time. So this one from 2014 when other time I gave the talk. Even then, we had over 40 million CPAN, oh, no, is that 4? You guys need commas on that website. I can't read it without commas. So over 40 million CPAN test reports. There were around 30,000 distributions on the CPAN, and it covers all sorts of things, different versions of the code, different platforms that it got tested on. Many modules only have a load test. Does it compile? So this doesn't actually tell you anything. You need to actually go in there and look at the code, understand what's actually happening. So one of the things I do, if I'm investigating a module, I'm not sure about it, I look at the test suite to find out, is this good? So don't blindly trust your tools just because they're out there. So unit tests versus integration tests. I won't spend too much time on this, but we try to like the idea of testing units in isolation, and they're very easy to write, easy to find errors, and they're very quick to execute. That's one of the great things about unit tests. They're very simple, very fast. You can write them fast. You can run them fast. Integration tests, you're testing groups of communicating units. They're hard to write, harder to write. They're harder to find the errors. If something goes wrong, you don't know where that error is, and they take longer to run. So why would you write integration tests? As I said earlier, your units are actually passing data all over the place. And if you just rely on unit tests, this doesn't verify the data that you're passing around all the time. So please be aware of this. So unit tests are a great tool, but you have to remember, like the Ruby community, I remember when they were really getting big on testing and talking about TDD and Cucumber and all this stuff, and they kept having conference talks about how fast can we make our test suite? So do you want it fast or correct? So So there were some interesting studies I found about this. One was little correlation between unit testing and post-unit defects, which I thought was rather amusing. That particular one, though, was based on surveys of people's opinions, expert engineers, but nonetheless opinions, so it was very dodgy. Most studies contradict that and say there is actually a correlation between unit tests and post-release defects, but you have to be aware of what this information is. If you want to make a hard decision about how I'm going to do a thing, try and get the data. So I could not find any studies which were comparing the value of integration versus unit tests, unfortunately. If anyone, yes? The question was, you didn't get to say it. Nice try. The question was, is that saying that the more unit tests you have, the more defects? No. It was not finding a correlation between the amount of unit testing and whether or not you had fewer defects. So, but that was only one study, and when I read through it, they were surveying engineers and not actually trying to do any analysis of what was happening there. So I didn't find it high value, but it was such a fun little study to mention on the slide that I couldn't resist. So let's look at integration tests again. This is an example that I mentioned earlier that we've developed cover would exercise a lot of code, and we only have one test down here. So none of this is actually tested. There is, however, a wonderful side effect of this. When you do stuff like this, yes, it's going to take longer to run. If you break your login somehow, this will catch it. Very good chance this will catch it. We do have in Untitled Station a lot of deep integration tests all over the place, which are exercising code and not actually testing it, because we're setting stuff up for, loading our fixtures and making sure everything's ready to test a particular feature, like launching a ship. And if we break something which causes that to fail, even though there's not a direct test for it, we will catch the error. It's annoying because sometimes you have trouble tracking down the error, but you can catch the error. And I would rather catch the error and have trouble finding it than not catch it. But again, they will take longer to run. So integration tests cost more, and they will find more. They will definitely find more bugs. Unit tests cost less, and they'll find less. But it's a trade-off. And sometimes unit test is perfectly appropriate when you've got this very difficult bit of code that's complicated, and you've got to make sure it's right. I'm not saying unit tests are bad at all. But I don't think, sometimes people want to go too far one way or another. Just be aware of the trade-offs on that, and don't be dogmatic about which way you want to go. Now again, we said that we're very test infected, but in fact, I don't think we're stealing enough. One of the things I've noticed is most people I'm seeing in the Perl community who get heavily involved in testing are talking about how do we test Perl stuff? And I would like to see more people go outside the community and see how they're testing their stuff to figure out ideas we can steal. So I've only seen one example of Perl of all pairs testing. So most bugs are just a single bogus bit of data passed in, the vast majority of them. Some are the interaction between two or more pieces of data, and then 3 or more parameter bugs, they're just less common. There are a number of studies which back this up. Amongst competent programmers write nearly correct programs. And so most faults are simple faults, and they're actually easy to detect, and all pairs testing is a nice technique which can help us do this. So, for example, we got some function here, and it takes a category, which has 10 values, subcategory, 150 values, is available, Boolean, so it's 2 values. You just do a naive multiplication on that, so that's 1,500, that's 3,000, you can say 3,000 tests if I want to cover everything. But actually it's more, because remember, you want it to break, so you want to try and inject, like file handles into your categories, stuff like that. So all pairs testing kind of looks like this. So for our first pair, we have arg1, arg2, and then arg1, arg3, arg1, arg4, then down here arg1 to arg10, assuming you had 10 args. And then your second pair, you don't do arg1, arg2 because you've already got that, arg2, arg3, arg2, arg4, etc. But then you have to assign the kinds of data you want for your tests. And then this actually figuring out on all pairs, I tried to do it because, this is trivial to do. And it turns out it becomes like sort of like the packing problem. It's solvable, but it's actually a pain in the tush. So all pairs testing actually allows you to do very, very fast generation of tests. They're likely to catch many more bugs. Multiple studies on this. And they're built into many tools for static languages. But static languages have an advantage. If they see that something's defined as a Boolean, they know you need to test both true and false for that particular parameter. We can't do that in Perl. So we've got to do some stuff manually. So here's more or less how it works. So here we got about a minimum of 3,000 test cases, but more because we need outbound values. So let's say category. Category has 10 values, but if we look at it, we might come up with 3 possible groups. One-time category, recurring category, and invalid. Always have some invalid data. So that's 3 arguments that we can test with instead of the 10. So for the second one, subcategory has 150 values. So groups, this is normal, virtual, discounted, premium. Again, invalid, because you've got to test invalid. So now we've got 5 values instead of 150. 2 values is available, Boolean, either true or false. We reject the invalid category here because we're going to assume that undef is false. And so right now, again, just doing a naive analysis, now that we're down to 3, 5, and 2, that's at least 90 plus tests, which is a heck of a lot better than 3,000. Again, it does require some analysis, and you're only going to take the time to do this for really sensitive bits of your code. But when all pairs code, you can contact me about this. I've got the link on my slide. All pairs testing actually reduces down to 15 cases. Those 15 cases, instead of 3,000 plus, are likely to find most, if not all, of your bugs in there. It's an absolutely wonderful technique. It's something we need to do more. So I've only found it on satisfice.com, download pairwise, testing a best practice that isn't. The problem is the code's GPL. Yes, you have a question. Right. Yes, it's not quite fuzzy. I love you guys. He said all pairs testing, you have to do this manually. It's kind of like fuzz testing because you can't generate the output. That's correct? More or less what you're saying? Okay. So not quite. It's not fuzz testing because you have to pick the types of inputs that you want to, and then it figures out all the combination of patterns that you can put as input to verify it. But at that point, you still have to write the test and say, for this combination of inputs, this is the output that I expect. And that's much easier to do with 15 instead of 3,000 plus. Your test might even run a little bit faster. So for this particular example, unfortunately, it's GPL, which is not a problem if you're using this for internal code. But I wanted to try and do something like this. It turns out the algorithm is actually very tricky to do, so I didn't get a chance to finish that before the conference. Oh, yes, go ahead and take your picture. You got it? Good. So, all pairs. Evaluating FDA recall class failures of medical devices found that out of 109 reports, 98% of failures could have been detected by testing the device with all pairs testing. That's from a 2002 study. This one, compared to a traditional company that would use the quasi-exhaustive strategy, that's the 3,000 plus tests, an innovative company using the combinatorial strategy, all pairs in this case, would reduce its system-level test schedule by 68% and save 67% in labor costs associated with the testing. It takes more time to figure out the categories and building the stuff up, but it saves you a lot of time in the actual writing of the test and making sure that you feel comfortable with it. Here's another one. More than 70% of bugs were detected with 2 or fewer conditions, and approximately 90% of the bugs were detected with 3 or fewer conditions. And it's interesting that a small number of conditions are sufficient to detect all reported errors for the browser and server software. And quite a number of all-pair studies. There's more than this. I just cherry-picked a few and put Sanchez at the top because he actually mentioned CPAN positively in there. He was quite pleased with that. There are some problems with all-pair testing. You have to use your head again. You got to think. So if you have very bad categorization, then you're going to get junk as your test results. The invalid cases people tend to forget about, passing in like a file handle instead of an object, what's going to happen with that. High-risk pairs. That's one of the critical things. If you have 2 pairs that really are likely to have a high risk to have bugs associated with them, or you cannot afford that particular combination to go bad, all pairs testing doesn't have any way of prioritizing that, so it's just something to be aware of. And if you ever adopt this technique, anytime you have numeric values, always, 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 always test 0. Always. Even if it doesn't allow 0, put 0 in there. Make sure it doesn't allow it correctly. What he said was that there's a similar idea of, for any numeric value, testing for 0, 1, and infinity. Yes, it's like, All numbers are 0, 1, and many. So, documentation. Tests are documentation, right? Okay, yeah, you've learned. No. So here's curry.t from regex common. There's a good reason it's called voodoo line noise. I have no idea what that is. We're testing real numbers. So 123.2345678 is a real number. 1234.23452, that's not a real number. I'm not entirely certain why. Is it because, there's a comma missing in that? I don't know. I can't tell from reading these tests. To me, this is very confusing. I think that's the case. Maybe it's not. Or here's the output from test harness. So I mentioned tap harness actually drives the current tap parser, but test harness is a wrapper around it. So when Andy Armstrong was working on that, we stole the tests from test harness 2.64, dropped them in our tcompat directory and ran them, made sure all of them passed. So simple lives, death never happened, error okay, too many... I have no idea what this output means. We were just blindly going through and making sure our test passed. I couldn't figure this out from this at all. Now here's my HTML TokeParser simple module. So my tests are can, the tag start can is tag, and it should identify a token as a given tag, and it shouldn't give false positives, and it should identify that the token is a tag. That's better, but it's not telling you what the code means. It's telling you what it does. So the business reasons for using this. So again, even me trying to be careful about this, tests are not documentation. They're often obfuscated. They're often incomplete. So obviously, if you want documentation, you've got like 25% test coverage, then you can't use that as documentation. There's all sorts of problems we have with tests as documentation, so stop thinking about them like that and stop promoting them like that. I use tests to figure out how the code works, but that doesn't tell me what it's supposed to do. If you want them to be test documentation, though, then you write them with the intent that they're going to be, the test code's going to be read and that the output is going to be read. And you want to describe the business cases that comes with this. So for example, subtest, overdrawn customers cannot purchase products. Does anyone not understand that? Okay, no hands, that's good. That's very clear. You now know the intent is that overdrawn customers cannot purchase products. You load your fixtures, you verify your overdrawn customer is actually overdrawn, and then you say that they cannot purchase that product. So it's clear. Now we're starting to get closer to test as documentation. Make sure when you're doing that, it's not just the output, it has to be the code itself. So customer purchase product is not as good as overdrawn customer purchase product, because then if you're reading the line in isolation, it's easier to see what's actually going on with that. If you're doing this test class moose, test methods, subtest overdrawn customers cannot purchase products. So once again, that's going to get into the test output, and you can actually read from that the business rules. So we have a custom test harness for Tau Station, which I think I'm the only one who uses, but it's really pretty. And I break up test names so that the underscores become spaces, and then I can have sickbay, test confined list, test confinement, test mod hint, test release now after confinement. I can at least get a sense of what's going on. So our names aren't perfect, but they're actually pretty good. So we do try to work hard to make sure that you read our tests so you can actually get an idea of what the intent is. There's also BDD for test documentation. I'm not going to go into that because I haven't used BDD before. It looks good. I really like the idea. We do have test BDD cucumber on the CPAN. I don't know how good that is. There's also Perl behavior-driven development, which you can see on SlideShare, which gives you an introduction to how that works. But I can't comment on that because I haven't used that, and I didn't bother to look for any studies on it. Here's the one which tends to get me into arguments with a few people, though. TDD is far superior testing methodology. Anyone believe that? I don't see any hands. Oh, I thought I did. Maybe you just hit it at the last moment. So I get this all the time. Oh, TDD is definitely better. You should be using TDD. Why aren't you using TDD? Well, first of all, I'd like to know what TDD is. There's so many different definitions I've heard, and it's expanded beyond the years. So a typical TDD study was evaluating the efficacy of test-driven development industrial test case studies. They were comparing it to non-TDD. TDD increased development time by 15%. Fair. TDD had far fewer defects than non-TDD. except I read that study. First of all, it didn't define what test-driven development was in this context. Some people, test-driven development is, okay, I've got my spec of the program. I'm going to write out all my tests and then fill them in. Others, usually, I will write a little bit of test, I'll make sure it fails, and then I'll write a little bit of code and then make sure the test passes. So there's different ways of having TDD, but they didn't define non-TDD at all. Was this non-TDD? Does that mean they didn't write tests? Does this mean they wrote tests afterwards? Does this mean they gave it to their QA department to test? Or they just, it compiles, ship it. Is that what they did? So I don't know what they're comparing it against. It was a complete straw man. And you get things like this all the time when you're studying these things. So it was very frustrating to me reading that. And here's from one study, a year-long empirical study performed at IBM using professional programmers found that TDD practice helps programmers produce higher quality code. Can someone define higher quality code for me? Because I couldn't understand. So in this particular case, they said a 40% reduced defect density. So that's higher quality? I don't know anything about the complexity of the code. Was it less costly to maintain, more costly? How easy was it to extend to use, whatever? If I've got an old legacy Perl website of 250,000 lines of code and they're not using strict, not using warnings, and everything's a mess and I can't figure out where everything is and they're concatenating SQL and they're using heredocs for HTML and it has no bugs, it's higher quality. So be very careful when you read the studies because you get all sorts of little things like this where they're not defining their terms. So they're often comparing their stuff against strawmen. They're often using students or single developers, which obviously doesn't map the real world. They're usually aware that they're being tested. And many of them have never used TDD before, so they're like, lab rats tossed into a cage. Can you please press this lever for me? But this is what I loved. Kane Marr, Ruby programmer, heavily into Scrum, huge TDD fan, talked to people all the time about how wonderful TDD was. And so he decided, I'm going to prove it. I'm going to get evidence. And he found the studies. And he expected that TDD was going to be proven to be effective because it's obviously so effective, the studies will demonstrate it. Every Pro-TDD study qualified their findings. And not a single study said absolutely use TDD. Not one. And he found that the studies themselves were rubbish. He did find there was a strong correlation across the studies. More tests meant fewer bugs. That doesn't sound surprising, which implies that possibly because TDD tends to produce more tests, that you're going to have fewer bugs. So maybe it's not TDD. Maybe you need to write tests. I don't know. It's just me. So he wrote, claims about TDD such as better design, better API, simpler design, lower complexity, increased productivity, more maintainable code, etc. are simply not supported by the evidence. He still recommends TDD. So he also, it's no longer online. He had a beautiful Google spreadsheet where he included all of his studies and the methodologies that they used and the defects that he found. It was fascinating. These studies are rubbish. And trying to study humans, if you're trying to study software, that's tricky. But now you're studying humans writing software and you've got this level of abstraction. It's tough. So I am not against TDD by any stretch of the imagination. I want to make this extremely clear. If you like TDD, use it. I tell my students, don't stress about it. If you want TDD, that's fine. But don't tell me the TDD is better. I don't want to hear this zealotry because it's a silly argument. It's like tabs versus spaces. Just shut up and write some code. So, summary of this. Basically, evidence trumps anecdotes. We know that. But we tend to rely on anecdotes. And if you don't have evidence, you got to start from somewhere. So yeah, your personal experience, that's fine. You can go ahead and use that. Code coverage is only part of what we need, though, to really have a good understanding of how our tests are behaving, what they're properly covering. You also have to think about this. So, and be skeptical of the hype, especially be skeptical of me. So if you're a TDD fanatic, don't sweat anecdotes. It's not a big deal. You don't have proof for this. Your studies are rubbish. That's fine. If you like TDD, use it. Everyone else, don't listen to the dogmatists. If anyone tends to use words, sorry, you should usually not listen to dogmatists. Oops, I talked too fast. So people who tend to use words like always, never, everything, etc., that's very scary. So always be careful about that, and particularly in testing. So at this point, I'm doing well on my time. Great. I am doing well on my time. Is that correct? So I have bonus slides or questions? Minutes? Okay. Yes. Sorry, Mark. I don't have to repeat it this time. No more moron comments.
It was just a comment saying that particularly if you've got development, staging and production environments, it can be really worth putting a lot more thought into the initial design to make sure you have got something which is testable. And I don't know if that matches up with test-driven design or not.
I think that's a very valid point, particularly when you have a company that has a QA department. Because if the QA department is halfway decent, they want to automate their testing. And as a general rule, I find that the harder the tests are to write, that's a code smell. And there's a good chance that there's a problem with the code. The easier the tests are to write, then the more likely that the code, I find, is going to be correct. So for your QA department, if you've got something decent, like you've got an API that you're writing against, for the BBC, we just had huge YAML documents, which would assert the inputs and then assert, all sorts of XPath expressions against the XML that we sent back to them. And it was very easy for them to automate this entire process because it was a good, clean, at least the API was a good design. The internals, we won't talk about that. Over there?
There's two words that came to mind when you were talking about all this.
I'm sorry, I can't hear you. Can you hold the mic closer?
Yeah. There was two words that came to my mind when you were giving the talk. One is fuzzing and the other is mutation testing. These are two tools that can bring you up to full confidence, almost certainty, that your code is working correctly when when you have full test coverage. So what do you think about fuzzing and mutation testing for determining code correctness?
Okay. Fuzzing, I have not used it before. The idea looks absolutely beautiful. Can you explain what you mean by mutation testing?
Okay, I define unit testing. No, I define mutation testing as when you have a full battery of tests across all your code. You have a program which drops out random parts of your code. And if your tests don't fail, then you know that piece hasn't been covered, in which case you can say, aha, you haven't covered the code, and it's a trick to figure out where you haven't integration tested your code. So it's a combination of fuzzing and mutation testing.
Okay, so fuzzing tends to be more black box. Mutation testing, I think, might be a little bit trickier with Perl, unless you're using like PPI, because are you just going to randomly insert, white space throughout your test code or stuff like that? You're going to have a better strategy. So I couldn't really comment about mutation testing, but fuzz testing looks lovely. Anything else?
Test. How did you get through this whole talk without a single animated image of unit testing versus integration testing? You didn't have a single one. How did you do that?
I tend not to put anything animated in my slides because it causes all sorts of interesting things at conferences.
Are there good approaches to automatically create tests, semi-automatically? Like tracking how the software runs, or having types for the input parameters, and just to know, well, for integer tests and so on, and to create them, and then the programmer can look over it and say, this is a good test, this is a bad test?
There are tools you can use which will assist with some of that. It's going to be a little bit harder with Perl because Perl doesn't have clear type information, which is something we want. Am I done? Okay, then ask me afterwards, and I'll talk to you about cyclomatic complexity and some tests which can be driven from that. Thank you.